Hi there, I'm García, and this is my PhD thesis in 3 minutes. My main research focus is the modeling and simulation of pedestrian dynamics. This is a relevant topic because we pedestrians are exposed to quite some major risks, such as overcrowding and infection disease transmission, such as in COVID-19 pandemic. And in order to tackle these problems, we work with the modeling of both pedestrian and infection dynamics. We build upon the so-called social force model, which simulates the motion of individual pedestrians based on 3 forces. And we calibrate the model to be able to reproduce both macroscopic sets of empirical data, such as this one, the pedestrian flow through a bottleneck, the speed density fundamental diagram, which relates the average speed of people as a function of the density of the system. Also, we achieve collision avoidance in simple pairwise trajectories. And finally, we are also able to reproduce collective patterns of formation, such as lane formation in bidirectional pedestrian flows. In addition, we present 2 novel extensions to the model. The first one is to capture queue formation. We are able to reproduce both comparative queues and also single file and ordered ones, such as in the GIFs on the left, and also decision-making of pedestrians, as we can see in the GIF on the right. Then we combine the developed methodology to study the crowd management protocols that were implemented during the 2024-2025 UEFA Europa League. We have the layout of the stadium, the geometry, and also the turnstile data, and we integrate all this information into simulations in order to calculate these density maps that can help the management interventions. Then we also simulate the infection dynamics at the microscopic scale in pedestrian systems. We built an approach based on the discretized diffusion equation, including the anisotropy of aerosol emission and absorption by pedestrians. And after assuming several concepts in the model, we simulate the transmission of an infectious disease, in this case COVID-19, into Galdacao San Solo Hospital. We conducted a survey with the nursing director of the hospital, and we know the average time that its healthcare workers spends with the patients, and also the rooms in which they work. So basically, in the simulation, we can see the viral load in the environment, which is emitted by the patients and then acquired by the healthcare workers who move around the environment, and after finishing their tasks in a specific room, they will move to the other, and this until they finish their working schedule. So in summary, in my thesis, we present a robust pedestrian dynamics simulation framework capable of reproducing both macroscopic and microscopic dynamics, 2 extensions of the model to encompass queue formation and decision making, a detailed study of the crowd management protocols in SAMAMES, and then a novel infection dynamics approach, which is eventually applied to Galdacao San Solo Hospital to study nosocomial contagion. Thank you for your attention.